Alright, today we're going to talk about section 8.2, properties of parallelograms. So our goal today is find angle and side measures in parallelograms. So our first thing we're going to talk about, what is a parallelogram? Our definition of a parallelogram is a quadrilateral, which we will abbreviate with just quad, with both pairs of opposite sides parallel. And remember, we use that double L, the slanted L for parallel. You will see this abbreviated as the abbreviation for parallelogram. I'm perfectly accepting if you want to use that as well. There are a couple other properties that we are going to discuss. The first of which, these are all in the form, if a quadrilateral is a parallelogram, then. So when you look at the book, realize that they're all written as if then. First one here, we notice about the sides. Opposite sides are congruent. If we look at the next one, we notice that we have angle markings, and you should notice that the opposite angles are congruent. Two more properties. These ones aren't as clear as the last two. What happens with a parallelogram is we know that these sides are parallel, which makes these two angles consecutive interior angles. It also works that these two sides are parallel, which means these two angles are consecutive interior. And if we recall, consecutive interior angles are supplementary, which means they add to be 180. So for any pair of angles, if they are consecutive angles, so we say the consecutive angles are supplementary. In other words, x plus y equals 180. And our fifth and final property of parallelograms, we have diagonals here, and if you can see, we have a double hash on this segment and a double hash on this segment. We have a single hash and a single hash. Again, if it divides into two congruent parts, we use the term bisect. So we will say that the diagonals bisect each other. So that is our fifth property of parallelograms. This section is basically just applying these properties. So here we have ABCD as a parallelogram. We're asked to solve for the variables. We know that opposite sides are congruent. So we have here 36 and y minus 8. So 36 is equal to y minus 8. We add the 8 to both sides and we get that y equals 44. Looking here, we have x is an angle, and the only other angle measure we have here is b. These are opposite angles, and we know that the opposite angles are congruent. So x equals 72. On our next example, we are working with diagonals. We know that the diagonals bisect one another, so it creates two pairs of congruent segments. So starting here with m, we know that 4m is equal to 16, and thus m equals 4, as well as 2n equals 9 minus n, because those two segments are congruent. And we add n to both sides and divide by 3, and we find that n equals 3. For our last example, it says here a metal protective screen on a door is comprised of many small parallelograms. So this would be a metal screen that would go over like a screen door or something you'd leave open in the summer. It's a little hard to see, but I have here a parallelogram drawn. So this is represented there. And it says that the measure of angle A is 110 degrees. And what is the measure of angle D? Well, let's pick a variable, maybe Z. D is not opposite of A, so it's not congruent, but we do recall that consecutive angles add together to form 180, and we subtract the 110 from both sides and find that the measure or Z equals 70, which is the measure of angle D. So we say the measure of angle D equals 70 degrees.